Good morning and welcome to another fantastic training from Regency Wire and Cable. I'm coming to you live from the Regency Wire bunker during this COVID-19 pandemic, and we're wishing everyone well out there in the marketplace, and we're all here to support you in any way we can. Today's topic is proper wire splicing techniques for two-wire decoder systems. We're going to go ahead and pass on this exquisite knowledge to you now. And again, we'd like to thank you for joining Regency Wire for this training presentation today. Two-wire decoder. Those two words can be used synonymously. We're going to talk about the proper tools that should be used when installing a two-wire system. We're going to talk about the connectors. Talk about the do's and don'ts out there with two-wire. We're going to talk about clamp meter testing. We're going to talk about voltage meter testing. The short circuit. Two-wire decoder systems are composed of sensitive electronics. The smallest short circuit will cause a malfunction. Conventional system splice quality is insufficient for two-wire decoder systems. It's the first thing you got to know. You can't use a standard system out there, splicing product out there on the market. You've got to use waterproof splices. Why is splicing so important out there? You can see here that this contractor is installing some Hunter two-wire products and decoder into the valve and the decoder on a job site. These are some of the tools that we suggest you use. On the left-hand side, these are some of the products that we sell and suggest you use every day in two-wire installations and wire installations. You must have a solid wire stripper that goes anywhere from 6" to 1/4 inch, and it must be a wire stripper that is 18 to 10 American wire gauge. That's AWG, and it must have that kind of capacity. Do not use the pocket knife that you see here or a box cutter. We don't recommend those items as you can damage the inner conductors. Proper wire connectors. This is an example of a wire connector that can be used in two-wire systems. It's the 3M Direct Berry Splice kit that comes from our friends at 3M and that we sell every day. It fits wires from 18 to 10 American wire gauge. First thing you want to do is ensure that the waterproof splice connector complies with National Electric Code UL 486D. These are two more examples here of some wire connectors that we recommend. The first connector at the top of the page is a Polaris connector. This wire connector can be used in fully submersible splice applications. You know, if you were in an area of a golf course or an area that flooded frequently and you were installing an irrigation system, this might be one of your choices. You want to ensure again that the waterproof wire splice connector complies with the NEC or the National Electric Code UL 486D recommendation. Again, it's 18 gauge to 10 gauge. We sell these in bigger gauges as well if you've got tray cable or something like that you're installing. Then in the bottom right hand corner, we've got the 3M 80 series. The 3M 80 series, when you take a look at it, it's a gel packed kit. It insulates and seals unshielded single conductor cables and multiple conductor cables. Splices non-shielded wet and dry cables. designed for weather exposed or direct burial locations. And we recommend this for the use of tray cables when powering up control boxes and pump stations and stuff of that nature. You can get this in a wide variety of sizes for any type of wire that's needed. It is UL listed and RoHS 2011 compliant, and it's also EU compliant. We sell these products every day. We're talking about the proper connector to use, and the connector most common in 2-wire systems would come from King or 3M. We never want to reuse those connectors, and that's the most important thing we can tell you about connector usage. We constantly have job sites where there's failures, where people reuse the connector, didn't have enough gel to ensure waterproofing. You want to strip the insulation of the innards 3/4 inches back with the wire ends even, and that's important. Insert them and tighten until secure into the wire nut. Insert the connector all the way to the bottom of the tube, not halfway, all the way to the bottom. Fold the wire into the channels and close that cap at the top. We're going to review this in just a moment again. These instructions cannot be more clear and must be followed to a T. If they are not, it will result in failures. When you're installing these decoder systems, as this contractor is here, we want to leave 3 to 5 feet of slack at each decoder location in a loop. This allows for settling, soil, and frost that can pull the connections apart. It also leaves you room if you've got to go back and change out a decoder or a valve. You can go back, you've got wire that's available to do that. When you're installing the decoders, avoid damage to the conducting wire when removing the outer jacket. Score the outer jacket, bend the wire at a cut until it snaps. That outer jacket snaps off. Slide the jacket off the inner conductor wires. Some cables have a ripcord to aid in the removal of the jacket. Cut a small notch in the end of the jacket and then pull the ripcord to remove and get ready to use your innards. You know, most of your wires that you buy from Regency Wire and the decoder type systems come with a nylon ripcord, so it's important to note that that differs in our products a little bit from everyone else. Going back to the installation of the fitting of the decoder, the typical sizes that you'll see in wires out there in decoder systems are 12 and 14 gauge. These are the common wire sizes you'll see. Again, you want to strip the ends 3/4 of an inch back of each conductor on the innards using the appropriate tool that won't damage the inner conductor wire or jacket. You want to twist the wires into the wire nut portion of the waterproof splice. And we recommend that you test the connections from the controller before adding water to the system. Here you see that contractor holding a finished splice. You want to insert the wire nut into that gel filled connector. If you'll notice, it's all the way to the bottom, not halfway, all the way to the bottom. That's important. And you know there's some slots in the 3M to run your wire nut down, to fit it in there and run it down all the way to the bottom. King connector does some things similarly to that. You want to push the splice completely into the waterproofing compound. There's gel in here, and that's what gives it its waterproof seal. You want to separate the 3 wires at the top coming out of the connector or the tube, and you want to push that lid closed until you hear it click, and you should be able to hear it click when you do that. Now we're going to take a look at some of the best practices along with your 2-wire installations that we recommend at Regency Wire and Cable. Place splices in a valve box. This is a pretty crucial step in protecting your electronics out in the field. It also makes them easier to locate in the event of a system failure. You want to install valve tags as you see up here. That way you can write these in on your as-builts and know where to go back and look when you're troubleshooting an issue. You want to make an as-built as you go. Keep a sketch of the notes throughout the installation and include the notes indicating decoder locations and other important information. Now we're going to talk about 2-wire solenoid testing. Roy's going to want to start out by noticing that these two pictures represent a multimeter at the top and then a clamp meter at the bottom left. The clamp meter is what you want to use when you're testing for 2-wire issues in the field and failures. The integrity of the entire decoder system relies on the 2-wire path. Can't be more clear about that. That's the difference between 2-wire and the rest of the system. Or a satellite system, I should say. The path is used to activate every valve in the system. So once one valve or decoder goes bad, the rest of the system is cut off. Using the clamp meter, look for the changes in the current down the path of the wire. The typical decoder uses 0.6 and to 5 milliamps. This will vary by brand. Let's say these use milliamps, or let's say these use 1 milliamp, excuse me. Another brand of clamp meter to use. You want to clamp around one wire at the start of the path. Current flow should reading of 100 milliamps with no solenoids activated should come up. You want to activate a zone. The energized solenoid will add about 200 milliamps of additional current flow. Consumption of the valve solenoid varies by brand and is published in the manufacturer's catalog. A system with 100 decoders of 1 milliamp each, the starting milliamps is 100. The reading of the 5th and 6th decoder should read 95 milliamps. Before the final 5 decoders, it should read 5 milliamps. Just to give you a quick example there. 2-wire solenoid issues. Continued. If change is seen in the logical progression, you know there's an issue like a break, bad splice, or leakage to ground, or a bad decoder. For example, if your design draw is 100 milliamps and you read only 30 at the controller, 70 of your decoders have been cut off from the system and you are not getting water. You're not able to irrigate in those areas and you're not able to run functional equipment. It's important we get that repaired. If we know the total system's normal milliamp draw before we start, simple checks can be done before field work to help determine what we're going to be looking for. Note that the milliamp draw for special device decoders will be higher when you're in the field. Generally, decoders for single valve operation will draw 0.5 to 1 milliamp. Multi-station pump or sensor decoders will draw 3 to 7 milliamps. The as-built drawing that we talked about earlier in this presentation can help you identify if these are used in your system. Excess current will indicate a short or open. Low main current will indicate a break or open splice. If you have a group of valves that don't turn on the fault will exist between the last working decoder and the first one that does not work. For example, at the 61st decoder down the path, our reading before the decoder should be 100 milliamps, as we discussed before, minus 60 or 40 milliamps, taking readings in the 61st valve box. We will probably find something other than 39 milliamps after this decoder. The tech can replace splices or change the decoder in an attempt to isolate the problem. If a bad splice, a damaged or bad decoder problem can be seen, or it could be the wire itself could be bad, the most common culprit is a bad splice. We can't stress that enough. 80% of the things we get called on at Regency Wire show that it's a bad splice. You'll notice the massive lightning picture here before we start this part of the training on 2-wire solenoids. When you're looking for damage in a system, it could be that you've got lightning damage to the decoder. Controller will exit short alarm mode when the decoder is replaced. So how would lightning, if we've grounded the system and done all that right, and that is a separate training that we offer at Regency Wire, and we've added ground plates and ground rods and all that type of stuff and done the necessary things to build a good system, how could we have lightning damage the decoder? So if you're not out checking your grounding on a regular basis, you could get yourself in trouble. Maybe you've got some soil that's a little hotter or a little issue, and maybe the ground rod has been eroded away and those types of things, and you don't have your system as protected as much as you think you do. So you can run into things like that. A 2-wire path is cable leaking to earth ground can be an intermittent problem depending on soil moisture level. When the soil is wet, the problem can create an error message at the controller. Earth ground faults are diagnosed from the controller when excess of current is in one of the 2 wires. Procedures for ground faults are similar to those for short circuits. Systematically isolate the parts in the system, check for damaged cables or bad splices. Now we're going to talk about voltage meter testing for satellite systems that you may run into out there. A voltmeter is an instrument used for measuring electrical potential difference between 2 points in an electrical current circuit. Analog voltmeters move a pointer across a scale in proportion to the voltage of the circuit. Digital voltmeters give a numerical display of voltage by using an analog to digital converter. A continuity test verifies that current will flow in an electrical circuit. For example, if that circuit is continuous. The test is performed by placing a small voltage between 2 or more endpoints in that circuit. These are the voltage meter symbols that you've got to become familiar with when you're out testing. You've got to take a look at AC voltage, alternating current, or DC voltage. It measures the DC electrical pressure in the line. Millivolts, amperes, measures the amount of electron flow. Milliamperes, ohms, measurement of resistance to flow the electrons. Diode, device used to control direction of electron flow. Audible continuity, audible indication of continuity for a low resistance. And then last but not least, capacitance, a device used to store electrical potential. It's really, really important that you understand these symbols on the far left-hand side of this chart. Without grasping or understanding the definitions of these, it's hard to move forward in testing. These are the steps you take when you're using voltage meters. And as you can see on the left, we've got them diagrammed out by numbers. You want to turn the dial to V with the tilde over the top. Some digital multimeters, or DMMs, as they're known in the industry, also include an M in front of that V with a tilde. If voltage in the circuit is unknown, set the range to the highest voltage setting and set the dial to V. Note that most multimeters power up in auto range mode. This automatically selects a measurement range based on voltage present. First, insert the black lead into the COM jack. I can't be more clear here, folks. These directions that we're about to discuss are very, very important unless you want to damage the controlled or the measuring device, or damage yourself or hurt yourself. Next, you want to insert the red lead into the ohms jack. When finished, remove the leads in reverse order, red first, then black. So when we enter this phase of testing, we go black first, then red, and then we reverse it coming out. Red first, then black. You want to connect the test leads to the circuit, as shown in the picture on the left. Black lead first, then red second. Note, AC voltage does not have polarity. It's important to note that. Caution, do not let your fingers touch the lead tips. Do not allow the tips to contact one another. Read the measurement in the display. When finished, remove the red lead first, black second. More voltage meter steps to follow. Turn the dial to the continuity test mode. Continuity test icon, as pointed out in the picture on the left. It likely shares the spot on the dial with one or more functions, usually resistance. With the test probes separated, the multimeter's display may show OL and ohms both. If required, press that continuity button before we start. First, insert the black test lead into the COM jack, then insert the red lead into the ohms jack. When finished, remove the leads in reverse order, red first, then black. With the circuit de-energized, connect the test leads across the component being tested. The position of the test leads is arbitrary. Please note that. Note that the component may need to be isolated from other components in the circuit. The digital multimeter, or DMM, beeps if the complete path of continuity is detected. If the circuit is open, the switch is the switch is in the off position, the DMM will not beep. When finished, turn the multimeter off to preserve battery life. Now we're going to talk about some voltage meter analysis as you're reading the reports you're getting from your device. In general, all AC voltage sources vary from fluctuation in AC voltage over power distribution systems. When different from an expected measurement, voltage is more likely to be lower than normal. Generally speaking, voltage measured in AC power systems should be within -10% to a +5% range. Voltage measurements taken in various points in a system vary. Refer to this chart below as a guideline. And these are some of the system voltage ranges you might find to find satisfactory or acceptable in points of use or service range when you're out testing. A little more of a testing overview on the DMM or the multimeter. Continuity is the presence of a complete path for current flow. A circuit is complete when the switch is closed. A digital multimeter's continuity test mode can be used to test switches, fuses, electrical connections, conductors, and other components. A good fuse, for example, should have continuity. A DMM emits an audible response or a beep when it detects a complete path. A beep, an audible indicator, permits technicians to focus on that testing that is so vital in these systems without looking at the multimeter display each time. When testing the continuity, a multimeter beeps based on the resistance and the component being tested. That resistance is determined by the range setting of the multimeter. If the range is set at 400, a multimeter typically beeps if the component has a resistance of 40 ohms or less. If the range is set at 4.000 k-ohms, a multimeter typically beeps if the component has a resistance of 200 ohms or less. The lowest range settings should be used when testing a circuit components that should have a low resistance value, such as electrical connections and switch contacts. Regency Wire would really like to thank you for participating in this training today. If you have any further questions, please contact me, Jimmy White, at 731-234-2372, or I can be reached at jwhite, that's the letter J, WHITE, at regencywire.com. Again, we'd like to thank you for participating today, and we hope all of your testing and training and installations go well. And we're here if you need us. Please don't hesitate to reach out.